So in chapter 7, you're going to get some questions that say prove and some questions that say solve. They're very different questions. Proof questions, we have to draw the line and only work on each side until they're the same. Solve questions are just equations where you want to solve for x. So can you combine like terms? And with question number 3, we're going to start getting solve questions that are also identity questions. You've seen questions similar to A before, but they've involved sine and cos squared. Now we have sine and cosecant. You cannot solve an equation easily if you have two different trig functions. So you have to come up with some way to either only have one trig function or separate the trig functions. In this case, I can use my identities and say I know that cosecant is 1 over sine x. And then I only have sine. But I also have sine in my denominator. Okay? First of all, I'm going to put this together. If I put that together, okay, imagine what fraction I'm going to write next in your head. Because sometimes students write this. Here, I'll do 2 possibilities. Sometimes students write this, and in black, sometimes students write this. So ask in your head what you would do if you were multiplying that 2 by 1 over sine x. Okay? Now that you have in your head which one you would do, the right one is the green one. Why? Because this is like 2 over 1. How do you multiply fractions? You multiply top. You don't also multiply the 2 on the bottom because it's 2 over 1. You multiply 1 times sine x on the bottom, you would just get 2 over sine x. So I wanted to point that out because if you're thought the black one, you want to make sure you understand why that's wrong. If you're multiplying fractions, you can always make a whole number into a fraction. Now, this is now reviewing rational equations from grade 11. In grade 11, you solved equations where there was an x in your denominator. You remember what you did to get rid of that? You multiply. We're going to do the same thing here. I'm going to multiply everything by sine x. If I multiply both sides by sine x, you see that this side would become 2 sine squared x. And if I multiplied this whole side by sine x, I would get 3 sine x plus 2. So I'm multiplying this side by sine x, and this side by sine x. Yes?
What if we choose to divide both sides?
Divide both sides by 2, you get a more complex fraction. So first we want to get rid of the sine x in the denominator. So the question started off as an identities question. You used an identity to get rid of it and make the signs the same. Now it's a reciprocal question from grade 11. So you multiply by sine x to get rid of the reciprocal, and now it's a quadratic equation from grade 11. So math does this. It really connects all of the things you've learned in the past and puts it together into a new question. Now, how do I solve a quadratic equation? I'm going to make one side equal to 0. And I'm going to factor. Okay. If this factors, it would have to be 2 sine x and sine x. Can I get my outside and inside to be 3? Yes, if I make my outside 4 sine x and my inside 1 sine x, I want a negative 3, so I'll make my outside negative 4 sine x plus 1 sine x. And now we've factored. completely. Every time you factor, you should check. Okay? The number one thing that happens as a mistake on tests, on quizzes, and the exam, some of you are already getting really good at collecting your E-errors, and the E2 happens over and over again. There's something about factoring, I'm not sure what it is. This is what happens. People don't write this equals 0 because they're factoring, and they get so excited, oh, I figured it out. They put the line, and they're like, yes, it's 1. I got this. I solved it. And I have to take off an E2 error, because there was an equal sign in this step. There's an equal sign in this step. In this step, you're missing the equal sign. And you actually, without that equal sign, it doesn't make sense to go to the next step. You need the equal 0 in order to be allowed to write this next step. So that E2 error comes up so often, right? Sometimes people need to collect 10 of them before they stop doing that. Some people collect only 2 or 3 and they're like, okay, I'm going to remember to keep an equation all the way through. Now, this is on my pie plate. Sin x equals -1/2. That's my pi over 6 family in quadrants 3 and quadrants 4. And this one's bigger than 1, so I can just write that it is not possible. Again, this, from this point on, is a great review for your chapter 6 test. Because you need to be able to solve this. I need to reread my question because I naturally solved between 0 and 2 pi. But I should see, is this, oh, thank goodness. It is, the domain is between 0 and 2 pi. So my answers are fine. I don't have to change it. All right. Did it ask anything else? No. I'm going to show you 2 ways that you can do part B. Okay? So for part B, again, you have sin x and you have cos x. So they're 2 different functions. So normally, this means that this equation is not easy to solve. But unfortunately, you can't change sin x into cos x or cos x into sin x. Sometimes people are tempted. You know how you can rearrange your big idea that sin squared x is 1 minus cos squared x? Right? So if there was a sin squared x, I could change it to 1 minus cos squared x. But since there's just a sin x, I can't. Okay? People are tempted. This is bad. I'll write it in red. This is bad. Sin x is not equal to 1 minus cos x. This is bad. You're tempted. Can you see how you'd be tempted? Can't I just square root both sides? But no. It doesn't work. I'll show you an example why it doesn't work. Would you agree that 3 squared, which is 9, is equal to 5 squared minus 4 squared? Right? If I take 9, it's equal to 25 minus 16. This is true. Okay? Check out the bad part. If you just said, is 3 equal to 5 minus 4? You just square root and get rid of, no, it's bad. 3 does not equal 5 minus 4. That's why this is bad. So again, you might be tempted by that, but there's no way to change sine to cos or cos to sine. Only sine squared to cos squared and cos squared to sine squared. So then how do we solve this question? Well, one way is just think about your pie plate. If you use your big idea, cos x is your x coordinate, sine x is your y coordinate. Are they ever the same on your pie plate? Yes. So if you use your pie plate, they're the same at pi over 4. Anywhere else? Yeah, in quadrant 3. 5 pi over 4. Okay? That's method 1, just using your pie plate. There is a method with identities. So a strategy that we did in the last question is we wanted to have only one trig function to solve. So what I'm going to do here is I'm going to do some identities to get only one trig function. I'm going to start by dividing both sides by cos x. Sometimes dividing both sides by something is dangerous because you might divide by 0. But in this case, if cos is 0, sine isn't 0, that's not a solution. But if I divide both sides by cos x, what can I change sine x over cos x to? I can change it to tan x. And now I have only one trig function. On your pie plate, is tan x ever equal to 1? Yes. Pi over 4 family. And tan is positive in quadrant 1 and quadrant 3. So then it would be the pi over 4 family in quadrant 1 and the pi over 4 family in quadrant 3. We get the same answer that we did in method 1, just using different logic to get there. Circle question number 10.